So going back, our equation is K times 16 times 10 to the negative 6 coulomb all over R squared is equal to K times 4 times 10 to the negative 6 coulomb all over 3 minus R squared. So take note that 3 minus R from our figure is 3. We have distance from Q1 to Q2 is 3. And then we have distance from P to Q1 is 3 minus D, or 3 minus R. This is just also equal to R. That is just the same thing. And we have in here our working equation. So simplifying this, we can now solve for the distance, or R. So distance, or D, is just equal to R, because they just they just talk about distance and nothing more. And we just have to copy the equation. 16 times 10 to the negative 6 coulomb all over R squared is equal to K times 4 times 10 to the negative 6 coulomb all over 3 minus R squared. So how are we going to simplify the equation? So both K are cancelled. So 16 times 10 to the negative 6 coulomb all over R squared is just equal to 4 times 10 to the negative 6 coulomb all over 3 minus R squared. By cross multiplication, 16 times 10 to the negative 6 coulomb multiplied by 3 minus R squared will just be equal to 4 times 10 to the negative 6 coulomb times R squared. So simplifying this, we'll be getting what? So we have in here 16 times 10 to the negative 6 coulomb all over 4 times 10 to the negative 6 coulomb, cancel coulomb, multiplied by 3 minus R squared is just equal to R squared. So this will be 4 times 3 minus R squared is equal to R squared, where R is just equal to D. R is equal to D. So this is our D. This will be our solution. By cross multiplication, this will now be our simplified equation. So how are we going to simplify this? So let's just copy the equation. So 4 multiplied by 3 minus R squared is just equal to R squared. So by this distributing, so 12 minus, I'm sorry, no, just have to simplify first 3 minus R squared. So I'm sorry. So 4 multiplied by, so simplifying, so 9 minus 6R plus R squared is just equal to R squared. And then distributing 4 to the equation, we have 36 minus 24R plus 4R squared is just equal to R squared. So we have in here our equation. So transposing R squared to the left side of the equation, we have 4R squared minus R squared minus 24R plus 36 is just equal to 0. Simplifying further, we have 3R squared minus 24R plus 36 is just equal to 0. So this type of equation is quadratic equation. So how are we going to do this? Quadratic equation. So remember, in your algebra, quadratic equation is negative b positive plus or minus square root of b squared minus 4ac all over 2a. So we have in here two roots because we are using square roots where we are evaluating. So from the equation, So from the equation, A is just equal to 3, P is equal to negative 24, and C is equal to 36. So substituting the values R, which is equal to D, is just equal to positive, negative, positive, negative, so positive or negative 2 meters. So this will be our answer. But take note that negative root is extraneous or not valid. So our answer would be positive 2 meters is equal to R is equal to D. That is just equal. This will be our final answer. And then for your assignment, list 5 conceptual examples of electric field and electric flux. When we say conceptual examples, it talks about a real thing, real application, or real life application of electric field and electric flux.